Hi, and welcome to Calendar Math with Miss Udo. I'm so glad you're joining me today. Do you know what month it is? Hmm, let's think. Well, my hint today is a little bit different. The month that we are currently in is spelled with three letters and begins with the sound. Do you know what month that is? Great. It is the month of May. Do you know what today is? We are almost at the end of the school week. We have one day left. So what day is it? That's right. Today is Thursday. Well, if today is Thursday, what was yesterday? You guessed it. Yesterday was Wednesday. Well, if yesterday was Wednesday and today is Thursday, what will tomorrow be? You got it. Tomorrow will be Friday. Let's take a look at our calendar. Remember, the calendar assigns one number to every day of the month. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What comes after 13? Did you say 14? You got it. Today is the 14th day of the month. So let's say our date together. Today is Thursday, May 14th, 2020. Let's try it one more time. Remember, we start with the day of the week, and then we say the month, the number, date, and then the year. Here we go. Today is Thursday, May 14th, 2020. Great job. All right, littles, let's take a look at your problem of the day. Our number for today is 14. And remember, this week we are using number sense strategies to find the missing add-in. And so we are going to use our handy dandy number bond. Where do you think I'm going to place the number 14? That's right, it's going in the big bubble. Can somebody tell me what it means for the number to be in the big bubble? That's right. The big bubble tells us our sum or our total. Well, the number we're going to use in one of our little bubbles today is 6. So 6 is one of our add-ins. Our other add-in is going to be a question mark because we don't know what it is yet. Remember, our two add-ins are going to come together to equal our sum, which is 14. How can we write this as a number sentence? Let's try together. What's our first add-in? 6. Exactly. And what is our operation? Well, if they're add-ins, our operation is addition. So we're going to use a plus sign. Remember, our missing add-in is going to be represented by our question mark. Because it is a number sentence, we have to have that's right, an equal sign. And all of this is going to equal the number in our big bubble, which is, you guessed it, 14. Great job. So now let's model our problem. Does anyone remember what we do first? Did you say start with the 14? You're absolutely correct. Let's draw 14 circles. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Great job. What are we going to do next? Did you say that we're going to color in 6 of our circles to represent our first add-in? If you did, you're absolutely correct. Let's do that together. 1, 2, 3, 4, 5, 6. Great job. So what do we have left to do? That's right. Now we can find out what our missing add-in is by coloring in all of our remaining circles and counting to see how many there are. Let's color and count together. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 extra circles and we colored them in red. So what is our missing add-in? That's right. Our missing add-in is 8. So 6 plus 8 equals 14. And 8 is the number that is missing from our number bond. Great job, littles. All right, middles, it's your turn. Here is your problem of the day. Compare 2/4 and 3/6. Remember, all this week, we have been using fraction strips to compare our numbers. Let's start with 2/4. Which of our fraction strips would we use to represent 2/4? Did you say the 1/4 pieces? If you did, you're absolutely correct. How do you know? That's right. Our denominator, or the number on the bottom of our fraction, tells us which of our tiles to use. Well, how many 1/4 tiles do we need to use to represent 2/4? That's right. We need 2. And we know that because our numerator is 2. 1/4, 2/4. Great job. Our next number that we're going to represent is 3/6. Which of our fraction strips are we going to use to represent 3/6, and how do you know? Did you say that we're going to use the 1/6 strips because our denominator is 6? If you did, you're absolutely correct. Well, how many of our 1/6 strips do we need to represent 3/6? Did you say 3? If you did, you're right on. 1/6, 2/6, 3/6. This looks a little different than any of our problems that we've done so far this week. Did you notice something? Both of those sets of fraction strips are the same length. This means that 2/4 and 3/6 are actually equivalent. What do you think that it means to be equivalent? Well, to be equivalent means that 2/4 and 3/6 are equal. So they are exactly the same. Great job, middles. All right, senior scholars, here's your problem. Remember, all this week we have been converting between various units of measurement, and we've been doing that via word problem. Our problem today says, Mr. Jeffries is buying water by the gallon for field day. He estimates that each student in the class will drink 2 cups of water. If there are 30 students in class, how many gallons of water will Mr. Jeffries buy? Well, first, let's figure out what 2 units we're going to need to convert between. I see gallons. Can you find the other unit? That's right, it's cups. And who remembers which of our friends is going to help us to do this conversion? That's right, my friend, the gallon man. Well, let's start by figuring out how many cups are in 1 gallon. Well, where's the gallon on our friend Gallon Man? That's right, it's the body. It's the biggest unit here. Well, how many cups are in a gallon? Well, we can take a look at Mr. Gallon's arms, and he's got 4 cups on each side, so 4 plus 4 is 8. And then we've got another 4 cups on each of his feet. So 4, 8, 12, 16. So we know that 1 gallon is equal to 16 cups. So what questions might we ask ourselves to solve this problem? The first question I would ask myself is how many cups of water will the entire class need? Well, let's take a look at our problem. There are 30 students in the class, and each student drinks 2 cups of water. So how can we figure out how much water he needs in cups? Did you say multiply 30 times 2? If you did, you're absolutely correct. And 30 times 2 is 60 cups. So the class needs 60 cups of water. Well, what's another question we might ask ourselves? Did you say how many gallons are equivalent to 60 cups? If you did, you're correct. Well, how are we going to figure that out? What if we divide 60 divided by 12? 60 divided by 16. Well, let's solve that together. 16 into 60. How many times does 16 go into 60? Did you say 3 times? If you did, you're correct. Well, what's the next step when we're dividing using the standard algorithm? That's right, we're going to multiply 16 times 3. Well, 16 times 3 is 48. What do we do next? You guessed it, we're going to subtract. 60 minus 48 is 12. And because we have a remainder and we are in 4th and 5th grade, we turn that remainder into a fraction. And so our answer is that 3 and 12, 16 gallons is equal to 60 cups. Can we simplify this fraction? We absolutely can. 12 sixteenths is equal to 3/4 because 4 goes evenly into each of these numbers. So are there any other questions we need to ask ourselves in order to solve our problem? How about how many gallons of water will Mr. Jeffries have to buy? Well, we know that 3 and 3/4 gallons of water will make sure that we have enough water for everyone. But can Mr. Jeffries go to the store and say he wants 3 and 3/4 gallons of water? No, he cannot. And so we're going to do some rounding here. Which direction do you think we need to round if we want to make sure we have enough water for the entire class? That's right, we'd have to round up. So where would we round 3 and 3/4 to? You guessed it, the nearest whole, and the nearest whole is 4 gallons. Great job, senior scholars. Well, thank you guys so much for joining me today on Calendar Math with Miss Udoh. Tomorrow is challenge day, and I look forward to posting the challenge problem for you all, having you solve it for a chance to win some really cool prizes. Until tomorrow, see ya.